निद्रा ले Good evening, one and all present here. I welcome you all for this fifth session of this ATAL FDP. Today, the first session resource person is Dr. A. Ravi, HOD of Electrical and Electronics Engineering, Francis Xavier Engineering College, Tirunelveli. So, Dr. Ravi completed his PhD in the area of power electronics and drives from Anna University, Chennai. He has published more than 25 papers. He has published more than 25 papers in the reputed journals and 60 patents with that. He's having 25 years of teaching experience. I welcome Dr. A. Ravi. Welcome you, sir.
Yes, welcome. Are you able to hear me?
Now I hand over the session to Dr. A. Ravi.
Yes, sir. Regan, are you able to hear? Voice audible? Is it audible, my voice?
Yes, sir. Your voice is audible, sir.
Okay. Yes, sir. Excellent. So good evening to all. So thanks to Mr. Reegan for providing this opportunity. So actually the session is about yes, sir. Yes, sir. Okay. Actually, the session is about interfacing of sensors with the microcontroller. That is a session. That is a title I have chosen. There are many techniques are there. Right. So there are many online platforms are there to interface the sensor with the microcontroller. So one of the basic fundamental online tool is Tinkercad, and the next one is Workweek. It is also one of the online platform to interface some of the microcontroller, especially the microcontroller which is carrying the basic use of uses Arduino. In that code, we have the Atmega 328 is the basic controller. So that is the Tinkercad have some drawbacks. Those drawbacks can be eliminated using a Workweek. In addition to that, all the microcontrollers, starting from big microcontroller to the latest Atmega controllers, we can use the Proteus platform through which we can develop many number of project in a simulation part without investing any money. So in this session, this next 1 hour, I'm going to demonstrate some of the projects related with the Arduino. That is with the Tinkercad platform. So here, let me share my screen. Yes. So I have shared my screen. Is the screen is visible to you, right?
Yes, sir.
So yes, sir. I have the web page called the Tinkercad web page. Is it able to see you all?
Sir, Ravi, sir. Kindly
Yes, sir.
scan on your camera.
Okay. Right. Is it okay? Right.
It's okay, sir.
Okay. So I have the Tinkercad platform. Actually, many of you know this Tinkercad platform, but I teach some of the codings, which is very basic codings in different manners to you all, right? So here we have the number of components. On the left side, we have the basic components which are using in any electronics project. We have the many small items are there, in which we have the. Let me talk with the Arduino controller, where we have the Atmega 328 processor, which is having 28 pins. Right. So let me talk about this sensor pins, and initially we will talk about the sensor pins, and later we will go further. Right. So here we have, when you see the actually to log in the Tinkercad platform, we must need a one Gmail account. Just in the Google, you type the word tinkercad.com. They will have some login, Gmail login, so through which you can easily log in into the into this Tinkercad platform. So there are many components are there. Here I have taken only one component. Basic component is Arduino. So when we see this Arduino, there are 14 digital pins are there, starting from 0 to 13. These are the digital pins. So through which we can give any type of input. Either it may be a digital pin, digital input or digital output. So generally we may call this as the GPIO pins, general purpose input output pins. So here we have the pin number 3, 5.
Participants, kindly wait. There is a technical glitch. Please wait, sir.
I was really
Sorry, network interruption. Actually, is my screen is visible? Regan, sir?
Yes, sir. It's visible right now, sir.
Okay. Actually, we stopped with the pin number, the explanation of the pin number. Yes. So we have 14 pins starting from 0 to 13 as a digital input output pin. In addition to that, we have the pin number 3, 5, and 9, 10, 11 are called as PWM pins through which we can control any power electronic circuits, right? Like this. So here, initially, this is the controller. We have Atmaha 328 key controller. We have. So to program this controller, we have the option called the code. Code, we have the three types. With three types. That is a block, and text, and a text. So we will practice with we must practice with always by writing the text program. So we have the program like this. So as a default, we have the program like in this program. It is a default program available in this coding. So we need to make some of the whatever code we want to write. We can replace. We can write the code as per our wish. So let me explain with the basic codes. Any coding having the two parts. First one is a setup part, and the next one is a loop. The setup part we must have in the if you see the Arduino board, we have the pin called capital L, that is called built-in LED. Inside the Arduino board, we have the built-in LED. So that LED will flow based on this program. That is a pin mode. LED built-in LED is the output. So we defined this LED built-in as the output pin, and this is the setup part. And in the loop part, it is the place where the program is continuously running. So the first command is a digital write. So digital meaning that either it may be a 1 or it may be 0. So this digital write, it is LED built-in is high. It is meaning that it is LED will glow for a second of 1000 millisecond, that we can call as 1 second. 1000 millisecond we can call this 1 second. So 1 second this LED will make high, and another 1 second this LED will be low. This is called pin number built-in LED. So we have the coding like this. After completion of this code, we need to make the simulation, that is called a start simulation. When we make the start simulation, this LED, so suppose you see here, if you see here, this LED will blink for a 1 second, and off for 1 second. It will on and off for 1 second. This is a very fundamental coding to understand the concept of what is Arduino programming. Right. So here in the next step is we will make stop this simulation. We will connect one of the basic component called LED. That is a red color LED. You can change the colors by clicking the color option. So red color, green color, yellow color, like that. We have the different colors. So we will make this. We have the terminals called the cathode and anode. So this always we know the cathode is a default. We will connect it into the ground. Next, in the anode pin, we will connect in the pin number 30. Pin number 30. So I didn't make any change in the coding. That the coding is as it is. So that is the LED built-in LED will glow for a second, and it will off for 1 second. So when we make this start simulation, in addition to this built-in LED, this 13th pin LED is also glowing for a second, and it is off for 1 second. So that means the default by built-in LED is nothing but 13th pin. So whenever we are writing any program, when we make the command, when we make the statement built-in LED, that is nothing but 13th pin output. 13th pin output. So here we have some error. It will show the error. That means this LED can withstand limited amount of current, but the current through this LED is very high. So in order to limit the current, we must have some resistor. So this we will stop this simulation, and we will delete this wire, and we will add some resistor here. Then through the resistor, we will connect to the anode terminal. Through the resistor, we will connect to the anode terminal, that is pin number 30. Again, when we make once again, when we start to make simulation, this LED, this previous error will not occur. It is not occur. The LED is glowing for a second, and it will off for another second. Right. So this is another next step of improving the coding. Again, when we again stop this simulation, again improve the coding like a pin number. Suppose we take pin number 5. Pin number 5, we will take pin number 5. Instead of a built-in LED, we will make the pin number 5. So this built-in LED, we will replace as pin number 5. Pin number 5 for high second for 1 second, and low for another second. So this is the next coding. Again, we will when we make the simulation, it is not working because we were connecting the diagram to the pin number 13. So let us stop simulation. We will connect this pin number 5. Pin number 5. Again, once we start pins, it will work. So the LED is on for 1 second and off for another second. So like this, we have the second very fundamental program to understand the LED project. Now, so this we will extend this project to a traffic light coding like this. Like we have in the traffic light, we must have three LEDs starting from red color, yellow color, and green. So we have one red color, and another next we will replace with another color. Next one is replaced with the yellow color, and one more LED is called a green color. We will call the green color, right? So we will connect all the cathode into the ground. All the cathodes are connected into the ground, and all the anodes are connected to the pin number 5 and the pin number 4 and the pin number 3. That means green is connected to 3, and the pin number 4 is connected to yellow, and the pin number 5 is connected to red color. So this is a arrangement of the traffic light. So here we have this traffic based on the requirement. We can on some of the light based on the timing. So here we will make again once again. We will make the change small changes in the coding. See here we have chosen three pins. We will copy the code and we will paste like this. So here pin number 5 and the pin number 4 and the pin number 3. So we are using 3 pins as the output. So in the for a traffic light system, at any point of time, only one light will on and the remaining 2 is off. That means we will make this coding. We will copy this digital write off. We will copy this digital write off. That is when the pin number 5 corresponding to red color, when it is high, remaining switches are off. Remaining switches are low. Remaining switches are low. So this is the first setup for first set of coding for a particular LED. And let us copy the same coding for another light, another set that is called low. That is pin number 5. That is red color is low. Red color is low, and the remaining things are high. Right. So this is for second set. Actually, this is also low. This is also low. Second one is low. And then next one is copy the same thing to the another one. That is pin number 3 is high. This is pin number 3 is high, and the remaining pins are low. Remaining pin number 5 and 4 are low. So this is I think this the program is initially we set up the pin numbers 5, 4, 3, and at a particular point of time, pin number 5 corresponding to red color will blow for a second, and the next one is pin number 4 corresponding to yellow color will blow for a second, and the pin number 3 that is which will on for a second. Like this we have the arrangement. Let us start the simulation. So when we make the simulation, this red color LED will on for a time, for a minute, for a second. So like this, we have the sequence of order. Suppose I want to turn on the red color for 5 seconds, means we just change the coding as here 5 seconds. When we make the 5 seconds in the here, the 5,000 milliseconds corresponding to 5 seconds. So when we make 5000 milliseconds in red color, that will flow for 5 seconds. And the remaining two lights are yellow and the green is for on for okay. So this is a very fundamental coding for a very fundamental coding for this Arduino examples. It has top simulation. So slowly we will go into the advanced coding. Here, so this is the platform we have. We can design a 3D designs and also electronic circuits. In the create tab, you can just make a create circuit. This is the place you can create any number, any type of circuit. Now here we will take the next one is called a small item called a right small circuit. We will call the small item called the SISO. That is, I will explain what is this SISO. Right. Right. So in the coding part, when we have the term called a serial monitor. We have the term called a serial monitor. So the working condition of the flow of working of this particular Arduino board, we can look into the serial monitor, which has a two part. The upper part is called output and the lower part is called input. So whatever text we want to give, that will be present in the lower part, and the output is in the upper part. So we can call it this is called the serial monitor. Serial monitor. When we make a double click, when we make it, which will make a hide. So when we click on this, which will make a present. Now here we have the first coding is called the serial monitor. How the serial monitor is working. So the particular pin is called. We have the term called a serial dot begin 9600. So this is called 9600 is nothing but we know very well. This is called the baud rate. So this is called baud rate. That means the number of bits per second, which is going into the Arduino board. This is called the 9600. There are many. There are some other advanced baud rates are there, but in the Arduino board we will use only 9600. So there are many reasons which will deal later. So the first one is serial dot begin. That is a first command we need to make, which will enable the serial monitor. The first command is serial dot begin. That will enable the serial monitor. Right? So that is the first part we need to make in the setup part. Next, we will take the next part. That is, we have the statement. We have the statement in the loop part. We have the statement called serial dot read. That means this command will read the serial monitor if any data is present or not. It should continuously reading. If that will be stored in the name of data. This is our wish. We can replace any word. Suppose I'm replacing with the small h. That is, this is serial dot read. Whatever the data is read, that will be stored in the name of x. So again, once the stored data that will print the stored data, that is exists, which will print in the serial dot print ln. This is the command we have. So next, when we make run of this command, right? So when you see the serial monitor, we have the serial monitor output is -1. See, the serial monitor output is -1. It is continuously present as -1 because I have not given any input. That means the input I am not giving. That will be present as -1. Because why it is present -1, meaning that the data type what I provide is the integer data type. Suppose I am giving the values. I'm giving the value 3. I'm giving the value 3. So that will be present as the 51. The 51, there is a reason. That we'll see later. Now here, in the serial monitor, there is no values are given. That will represent as a -1. I have not given the input. That will be represented as -1 because the data type is integer data type. Cold. I'll make the start simulation. Character. I'll make the data type is character. That is, whatever data is read, that will be stored in the value x. The x data type is character. Again, when we make the run this start simulation of this program, we have the output called y, like that y double dot we have. This is called the garbage value. We will call as this term we will be called as garbage value. That means no data is available, nothing is available, like that we have. So that means this coding is to enable what is serial input and what is serial output. That means whatever data we are giving, suppose I'm giving the value a, that will represent as a small a. So the character value is going as it is, a. Suppose I'm giving like that. Two words or two letters success we are giving, that will be present in the one by one manner. It is becoming it because I'm using the command called a print ln. Print ln means the command the whatever word we are giving, that will be present in the one by one manner. It will be coming as a that is called serial dot print ln. Okay, stop. So this is the second one. This is the second one, that is called serial input and serial output. Again, we have the next coding called small coding is called, we have the RGB LED. We have the small code next coding is called RGB LED. RGB LED is a single LED which will make different colors based on the command we are giving. Based on the command, so the terminals are red color and cathode blue and green. So it is a common cathode. A single cathode are different colors. The three colors are that. This is called red, blue, and green. RGB LED. Okay. So this RG based on the input we are giving. Based on the input we are giving, this light will make the different colors. So for that we have the small website is there. So there we can make a different color, that is called a W3 RGB W3. Right. So here we have RGB calculator. Based on the input, there are three letters are there. RGB. The first letter corresponding to R, and the second letter corresponding to G, and the third one is corresponding to P. That is the maximum contribution is 255. Why? Because 255 means we have this controller. Whatever controller we are using, it is called the 8-bit controller. So 2 power 8 is called 2 power 8 is 256. That is starting from 0 to 255. The total number is 256. So we have the term called 255. That means the contribution of red color is 255. The contribution of a green color is 0, and the contribution of a blue color is 0. Suppose I make a slight change in the first contribution, that is the red color contribution. When I make a 100, so that becomes the color becomes somewhat a dull. That is again when we make the contribution of a green color, that is 100. This will make a different color. That is a combination of red and green. Again, when we make this blue color as 100, this 100, this will make a different color. So the maximum value you can give as 255. That is a maximum value we can give. Suppose when we make all the color is when we make all the color contribution is 0, can we say what color we can expect? When we make all the color as 0, what color we can expect? Right? Anyone? When we make all the contribution of red, green, and blue, the contribution is 0, what color we can expect? We can expect the color is black color, right? Black color. Again, in the opposite manner, when we make all the contribution is 255, 255, that is the maximum value. So red color is 255 and the green color is 255, blue color is 255. Again, the contribution is a pure white. We have the full contribution is very good. Pure white we have. So that is the maximum contribution is 255. That is the limit we can write. So based on the values given to the coding, there is a separate codings are there, but that I am not dealing. Based on the values for red color, green color, blue color, based on the values given to the corresponding LED, we can get the color of different colors we can appear into the LED. Right? So this is a next thing. A next thing I want to insist. Right? So based on the color, we can get the limit. Right? And right. So next one is next coding is about a SISO LED. So actually, this work I have done previously just for demonstrating the work. I have taken all the thing. Right. Right. So here, this is the coding. Suppose we see the coding of this particular circuit is. Right. We have the code. First, we were enable the serial monitor by entering the word 9600. Then we are using the pin number 6 as the output. These two are the setup part we are making. In the loop part, we are writing some small coding. Let me explain the coding, then I will demonstrate. The first one is if a serial available. Suppose if any data is available in the serial monitor, the bottom side is called the serial monitor. If any data is available in the serial monitor, it will check continuously. That is, if serial dot available. If it is available, then it will go into the next line. If it is available, it will read the data. It will read the data and stores in the name of X. In the name of which is our desire, we can replace any word. That X data type is character. So once if it is read, that will be stored in the name of X. After storing, it will print the word X. It will print the word X. If X value is 1, then it will go into the next part. It will go into the next part. That is a digital. If X value is 1, that means that this sixth pin is high. The sixth pin, so you are connected in the diagram. If you see in the diagram, in the sixth pin, we were connecting a one LED. So here, if X value is 1, the sixth pin is high. In addition to that, the print it will make the print LEDs on. And in the opposite manner, if the value is 0, the value what I am entering is 0, the sixth pin is low. That is, the sixth pin is low. That will make the value as LEDs off. Right. So here, I'll enter the word 1. I'll enter the word 1. That when I make the send, I'll make a start simulation first. I must simulate this circuit, right? When I make the simulation of this circuit, then this I will make it by entering 1. Right. So I enter the word. I enter the letter 1. It is a character. So when we make the character, the LED will glow. That is a program we have written. That means when we enter the letter 1, the LED will make high. In addition to that, we must have the word called LED is on. Again, when I enter 0, when I enter 0, it will that will be it will make the output as 0. That is LEDs off. In addition to that, LEDs off. So like that, we have the next coding called a interfacing of interface. That is by making by user control, we can turn on the light or turn off the light based on our user control. Based on user text 1 and 0, we can turn on and turn off the light. So this is the next circuit. So actually, this platform, whatever we practiced, whatever we worked, that will be stored as a default. Whenever you can wherever you log in, you can get back this circuit, right? Right. So the next one is here we have the arrangement called this is called the potentiometer. Everyone we do based on the arrangement of potentiometer. The brightness of the light lamp is varied. The brightness of the lamp is varied based on the potentiometer arrangement. So how we can interface this potentiometer with the lamp control brightness. So that is a thing next project we will see. So here we have the coding, small coding. So let me explain this coding. So as we said previously, having in this entire program having two parts. The first one is called the setup part, and the next part is a loop. In the setup part, we were enabling the serial monitor. Then pin number 6 is the output. That is the next one. Then we have one more command called pin mode A not. Here with the bottom side we have the six sensor. The analog sensors we can connect, that is A not to A5. Analog sensors we can connect A0, A1, A2, A3 up to A5. That is six sensor. So in the sixth A0 is we are telling us the we are defining as the input. We are defining as the input. So that is A0 pin is the input where we connected the potentiometer. So in the in the loop part, so here we have term called analog reading. The previously we have the called the digital read. Now we have the next one is called analog read. Analog read of which pin, that is A0 pin, which will read continuously. That will be stored in the name of X. That is our desire, our value, our intention. We can give any value of any number, any of the values. Here I'm using the word called X. Here there you can replace anything you want to use, you can use. So that will be that will be stored in the name of a integer data type, right? So again, this whatever data is read, that will be printed the serial monitor. After printing the serial monitor, that value is written into the right of the sixth pin, analog write. Whatever value is read from the value analog read A0, that will be written into the sixth pin where we connected the that is a lamp. Then we make the delay of 1 second. This loop will work continuously. This loop will work continuously. So, again, when we make the start simulation, so this LED lamp is glowing. Now, suppose we want to, I'm varying the values of voltage, that is a potentiometer. When we make the change of potential meter, the brightness of the light is getting changed. So in the online we cannot you can see the brightness light is getting changed by varying the dial of the potentiometer. So this is next one. Next small project, that is introduction of analog read and analog write. So the previously we have taken digital read and digital write. Now here we have the term called analog read and analog write. So just introducing this term called analog read and analog read. So that means we can analog sensor, wherever we are connecting analog sensors, you can place the word analog read and analog write. So this is next one. Hold. the next project is about so the next project is LED dimmer. Right. Yes. So the next one is a LED dimmer. So that also I worked previously. So in this circuit, you can observe some of the device called the buzzer, which is connected to the pin number 9 of the board, and the LED, which is connected to pin number 3, and in addition to that, we have the potential meter arrangement. So when we see the coding of this circuit, when we see the coding of the circuit, this is slightly different. Now here, as we said previously, having two parts. First part is setup part. In the setup part, we initiate with the pin number 3 is the output. Pin number 3, we have connected a LED, that is the output. And the pin number A0, the previous example we have seen, A0 is the input. A0 is the input where we connected the one of the analog input, that is called a potentiometer. Right. So here this analog read whatever data. Correct. So whatever data read from the A0 value, that it is stored in that name called a data. So here I have not defined any data type because initially I defined a data whose data type is the integer. So initially I have defined, so I need not define once again here. Again, whatever data is read, that will be mapped. We have the term called we have the syntax called a mapping of two values. Here I have two devices. That means based on the potential meter variation, the LED will make a brightness or low. That is, LED will make low based. LED will make the brightness based on the input given to the potentiometer. So that means I am using two devices. One device is called the potentiometer and another one is called the LED. So that the two devices I need to map. So we have the term called a mapping function in the Arduino. So the mapping of which we need to map means data. The data we need to map for the devices 0 to 1023, which is corresponding to the potentiometer. That is a which is a very maximum of 1024. That is a 2 power 10. That is a 1024. That is 0 to 200 and 1023. Total value is 1024. Right. Next one is next device is called the LED, whose values ranges from 0 to 255. There are two devices I am going to map. So after mapping, that value is stored in the name of Y, whose data type is integer data type. As we defined in previous first line, Y data type is integer, right? So after that, we were writing analog write whatever value is stored in the value Y, that will be written into the third pin based on the analog input given, that value will be stored in the Y. That will be write into the device called a LED. That is called analog write. If Y value is again if next device we are introducing, that is if Y value is less than 225, that is maximum value is 225. If Y value is less than 225, no buzzer. The buzzer will not make any sound. No tone buzzer. It is a command. It is a syntax in buzzer. That is a no tone buzzer. Else the buzzer will make the sound of 700. This is a sound tone of 700, which will make some sound, which will make some sound. So this loop will continue. This entire loop will continue as long as we terminate the program. Again, when we make the start simulation. Now here, when we see here, this LED will make a glow. You see, LED will make the. We will also enable the serial monitor because we want to see the values. So here the values corresponding to the position of the dial is changed. When we change the position dial position, it will get changed. So now the position is 112. Now when we change the position of the dial, maximum we have when we make a when we make it 255 less than 225 there is no sound, or when it reaches max more than 225 there's sound, right? So this is the way we can make we can control the any when we for any project if the value is exceeding the limit that will make the alarm to us. So like this we can make the project. So this LED dimmer, when the values particular values sensor values reached above the threshold value, that will make the buzzer. So here we have taken the value 255 is the value we have taken. So this is the next one where we are taking, that is LED dimmer, that is analog sensor. That is the first analog sensor we are seeing is potentiometer. It is an analog input sensor we can see. Right. So next we can see the next one is called a PIR sensor. So this PIR sensor is available here. When we make a type PIR sensor means here we have the PIR sensor. This PIR sensor having the three terminals. The first terminal is ground. Ground is connected to the Arduino ground. And the second terminal is the power input, which will be given to the 5 volt. The Arduino 5 volt pin we are giving. And the output of the pin is signal is connected to the pin number 3 of the Arduino. Pin number 3 of the Arduino. So here, how this analog sensor, this sensor is working. Actually, we can say this PIR sensor is a digital sensor. So we are giving the whatever data is read from the sensor, that will be given into the pin number 3. Right. It is a small project. So here pin number 3 is the input. That is whatever sensor is whatever values read from the sensor, that it is given to the input of the pin number. So pin number 3 is the input. Next time is we were enabling the serial monitor. The what is the loop? What is the function it need to perform means. So it will read the digital values from the first line digital read pin number 3. That is, it will read the value of pin number 3, that it is stored in the name of data whose data type is integer. So this data is our choice. We can replace Q. I am just making the word Q. Again, here also we are making the word Q. So we keep just changing the value. This is our say. We can put any number. Just this coding is over. That is a delay is given for 500 milliseconds. We can give any delay as per our wish. And when we make the short simulation, so here digital means this sensor is not now, it is not working. So actually PIR sensor is a sensor that will detect the living being. What suppose a living being, it may be a small animal, or what it is a human being, whatever may be, who say it is a living being, it will sensor. Based on the sensor value, it will give the input to the Arduino board. So here I am making I'm just any, suppose this is the way we can run right now. Just to minimize, right? So here this is the place the sensor is working. Now the sensor is sensing the values. That is, we have the red color in the sensor. The sensor senses, that means something is present in front of the sensor. So it will show the values. Yeah, it will show the values to whom? Serial monitor. That means it will read the value and in place the letter Q. The Q, whatever value stored in the letter Q, that will be printed in the serial monitor. Suppose when I make the sensor to sense, just see, suppose we have sensor, the sensor will make the sensor will make the red color, two red colors in the sensor. When it senses in the serial monitor, it will present the value 1. That means if something is present in front of the sensor, like that it will show. When I click the sensor, the value will be present in the serial monitor. So this digital PIR sensor is a digital sensor. Some places we can use for analog sensor. Based on the project, we can use some of the project we can use this PIR sensor is analog sensor. But here we are using the PIR sensor as a digital sensor that will sense the values. It will convert as a binary numbers. Either it may be 0 or 1. Now here is nothing is present. The output sources is 0. Continuously, the serial monitor output is 0. When I click the sensor, that means the sensor two dots are there. So whenever two dots are there, this sensor senses the value, it will present the value as 1. In the serial monitor, it will present the value as 1. So like that, we have the second basic sensor is called PIR sensor. Many of the live applications, we have this PIR sensor. So in extending this PIR sensor, we have one circuit called a we have small applications. So in this application, we have a number of devices, PIR sensor, and next one is a small LED placed in the breadboard, and we have the small motor, that is a servo motor we have. Based on this servo motor will make the rotation based on the input given. So let us see the coding of this diagram. So we have small coding. So the first line is a header file. So we are using a small device called a servo motor, which has a heading of servo.h. So which is a header file we need to add. So again, next line is the servo motor. The servo motor will having the function of a servo. My servo is the function we need to use whenever we are using the servo motor. In addition to that, we have the LED pin number 13. Pin number 13, we have the LED, and the PIR sensor is connected to pin number 2. And initially, it is a value PIR status is 0, and the position of the servo motor is 0. So like this, we have some initial arrangement. So all the initial arrangements, we have the data type is integer data types. That is LED, PIR, and the status of the PIR sensor, and the position of the servo motor, all the sensor, all the arrangement, we have the data type is now. So after arranging this, we need to define which are all the component are working as input, and what are all the component working as the output. So here LED pin, this is the output pin, and the PIR is the input. That is the PIR sensor will sense the value. Based on the sensed value, this LED will make a output. And again, this my servo motor is a function which is attached to the pin number 9. This is servo motor Arduino board. It should be connected into the pin number 9. See, the pin number 9, the servo motor is connected. So this is the arrangement setup part we need to make. Setup part. Now again, PIR status, that is PIR sensor status is will read the digital value of a pin number. That is a PIR sensor pin number 12. Pin number 2. A digital sense of pin number 2. So that means it will read the value of a PIR sensor that will be stored in the name of a PIR status. So this is our choice. We can replace whatever data we can write. So that PIR status is high. When this status is high, then this LED will make LED pin is high. When PIR status is high, that is the digital value of PIR sensor is 1. This LED pin is high. Otherwise, it is off. Again, in addition to that, it will make the pin motor will make the rotation of 0 to 180 by an angle of by values of by increment of 1 like this. It will increase 1 degree. It will make an increment, right? So this is the arrangement. So like that, we have the small coding. When we make the when we run this simulation, when we run this simulation, we have the arrangement. See, this servo motor is rotating, but this LED will not make any effect. So when we place any of the values near to the sensor, that is in the sensor, when it senses two red color dots or hotspot are there. So based on the hotspot, the LED will glow. LED, that means here something is present. Like that, the sensor will sense the value. Based on the sensed value, this LED will make an glow. Suppose see here, when we make click, the two hotspot, red color hotspot that are there. Based on the value, the LED will make it glow. So this is next sensor we have, PIR sensor. It's some small applications based on the sensor. One servo motor, the servo motor real-time applications we can use as a door. We can replace the servo motor as a door based on the sensed value. This door will make open or closed based on the sensed. If any person is coming in front of the sensor, the servo motor will rotate. That means the door will open. Like that, we have a small project. We can use a PIR sensor and the servo motor. We can interface. So next sensor is so the next sensor we have is called a force sensor. So when we make a type of force, so the force sensor is available. So you can place it, just you can drop the sensor and you can place wherever you want to use. So this is again, this is force sensor having the terminals pin number 1 and pin number 2. So this pin number 2 is connected to the A0 of, that is analog input of the sensor. So the A0 meaning that, so this force sensor here, it will be act as a input, that is A0 is the analog that will be read the. Now when we make the coding of this sensor, now the first line is a red color LED is connected to pin number 2, whose data type is integer data type. And the setup part of this coding is, so red color LED, that is pin number 2, LED is acting as a output. We were enabling the serial monitor by making the command serial.begin. Now here, this since we were connecting this force sensor, that is connected to A0, that is called analog sensor. So the analog value, whatever is read from the A0, that it is stored in the name of we can use a small letter called S. We can use a small letter. So whatever value read from the sensor, that it is stored in the name S, whose data type is float. We can use integer also. We make integer means we will get some exact integer value. But here we are using the accurate value. We are using the float. If this S value is greater than high, we were stored in the name of S. If the S value is greater than high, then this LED will make high. That is a high. The LED will on. Otherwise, it will be off. Else the LED is off. Like that, we have the small program. This again we have the name called yes. It's a very simple program. When the range is, when the force value is greater than 700, that means the LED will make a high. LED will become high on. Otherwise, it will be low. So that the values we can measure from the serial monitor, enabling the serial monitor just to make the simulation of this circuit. Right. So initially the values, the force values 0.00 like that. Since we are using the data type called the float, we are using the data type float. Now it will make the decimal point like this. Now when we change the right, when we click the force sensor, we have the cursor. When we make the force value, slowly the force value is also varying in the serial monitor. So you look at the values in the serial monitor. The serial monitor values also gradually increases. When it reaches 700, when greater than 700, that is the coding we have written. When the force values reaches some more than 700, that time the LED will make on. See, the LED is on. Now the force values is 729. When we reduce the force value, the LEDs becomes off. Again off, again off. So here you can connect one buzzer. Suppose instead of this LED, you can make some buzzer that will make the sound. Let us try that. We will take the buzzer from the component list. We will have the component list. In the component list, we will have the buzzer. So delete this. We can connect this +2 this terminal and -2 this terminal. Right. So we were making the, instead of LED, we are connecting a buzzer. Right. Again, we are enabling the serial monitor. Now the force value is 0. When we keep on increase this force value, when it reaches more than 700, now it will make the sound. When it reaches more than 700, that is the coding we have written. That will make the sound to us. That will make the alarm to us. The force value is going beyond the limit. So that will make the sound alarm to us. Right. So this is the thing we can see, and we have the last one more sensor. Many sensors there, but we can practice with some of the basic sensors. And the next one is called a ultrasonic sensor. Okay. So we can work a ultrasonic sensor also. Now here, actually, this Tinkercad is the open platform where you can work any type of circuit. Suppose I want to play one simple song, a happy birthday song, means just in the Google you make a happy birthday Tinkercad. When we make a like the keyboard called a happy birthday Tinkercad, when we make the keyboard, which will make some project. It is a designed by someone. You can make yourself as this coding copy and tinker. So this is the circuit which will play the song Happy Birthday tone when we make the play. That is a simulation, start simulation. This will play Happy Birthday song. So like this, it's an open platform. Many persons work on this one. It should be stored in the open platform. Anyone can who register in the Tinkercad platform, they can utilize this Tinkercad platform. So this is the thing. So like this, we can work many projects related with this Tinkercad platform. So this is the thing I wanted. There are some more projects are there, which I have not planned to explain. I plan to explain only this up to PAR sensor and the ultrasonic sensor and the serial input, serial output, like that only I plan to explain. So this is a time to complete. Right? So if any queries related with my presentation, you can ask. Otherwise, we can wind up. Yes, sir. You can, sir.
Thank you, sir. Thank you very much for your wonderful presentation.
Yes, sir.
Participants, if you have any queries, kindly type it in the chat box. Participants, if you have any query, kindly type it in the chat box.
Actually, sir, for Prasant, I have one document called I prepared myself this Tinkercad, so that I will share the link here. So if you want, you can use it. I have practiced many codings related with this Tinkercad. So I will share the copy here.
Ravi sir, kindly unmute your mic and speak, sir. Ravi sir, kindly unmute your mic and speak, sir.
Yes, sir. Okay, right. So this is a document I have prepared myself. In this document, you can refer a lot of projects related with the Arduino and the Tinkercad. Many sensors I have connected and practiced in this link, so you can practice. So I posted this link into the chat box. You can use that. Yes, sir. Yes, sir. So this is a document, Google document I have prepared. So you can download it and you can work it, sir. Oh, yes.
Participants, any other queries? So thank you very much, sir.
Yes. Yes, yes, yes,
Thank
yes,
you
sir.
very much.
Thank you, sir.
Thank you for sharing your valuable ideas and
Yes, sir.
thoughts
Thank you,
with
thank you,
us.
sir.
And
Thank you, sir.
I'm very thankful to you. And thank you. Once again, I thank you for sharing your valuable time with us, sir. Thank you very much, sir. Thank you. Deepak, sir, surely we will share it in the WhatsApp chat, sir.
Yes, sir. Okay. Thank you, sir.
Thank
Can
you.
I about document sir? Yes, sir. Sir, I will make the permission, sir. Whoever requesting me, I will make the permission, sir. No issue, sir. Access at any time. Some of the I just am receiving the request. I will make the permission, sir. No issues. Thank you. Again, sir. Can I leave?
Yes, sir. Thank you, sir.
Yes, sir. Okay. Thank you. Thank you. Thank you.
Participants, don't leave. The second session will start in within few minutes. Good evening. One of our present here. So, the next session will be handled by Dr. Nafina Abdul Munaf. Dr. Nafina Abdul Munaf, a highly accomplished individual in the field of electrical and electronics engineering. She completed her undergraduate program at PSNA College of Engineering and Technology in May 2003. Continuing her educational journey, she obtained her master's degree from Crescent Engineering College, Chennai in June 2025. So 2005. In 2019, she successfully completed her PhD program in electrical engineering at Anna University. Dr. Nafina has amassed an impressive 17 years of teaching experience across various renowned engineering colleges and universities. Currently, she holds the position of assistant professor at Villa College, Maldives. In addition to her teaching expertise, she has made significant contributions to the academic community through her research. She has published 7 papers in esteemed journals such as Scopus, Web of Science, Science Index, and UGC. Notably, her paper titled An ML Approach for Household Power Consumption, published in IEEE, has garnered 49 citations. Currently, she holds esteemed role of a reviewer in renowned international and national journals. Additionally, she has had the privilege of delivering numerous captivating keynote lectures at prestigious colleges and universities, focusing on patent filing rights and sustainability issues in the environment. Her passion for writing extends to crafting enlightening articles and publishing them on the fascinating topics of life cycle analysis for various products. Notably, her groundbreaking research of life cycle analysis of laptop was published in Research Digest magazine of Villa College. Furthermore, she has been granted funds to delve into the realm of life cycle analysis and recycle of waste lube oil, with a focus on transforming it into plastics. In her quest to promote safety, she has organized electric safety awareness programs catering to both students and technicians. Her exceptional skills have earned her multiple best project awards in the field of electrical engineering. Above all, she possesses an unwavering enthusiasm for engaging with and educating young minds, empowering them to achieve prosperity in their lives. I welcome Dr. Nafina to hand over to take the session.
Thank you so much for a nice introduction about me. I hope, am I audible?
Yes, ma'am, you are audible,
Am
ma'am.
I audible?
Yes, ma'am, you
Okay.
are audible.
Okay. So thank you for organizing this wonderful sessions. And then I would also like to acknowledge the organizing team, Mr. Regan and Dr. Joe Patrick, who has invited me to deliver a session on the title Environment Monitoring Sensors. I hope we will network in this session, and then the key takeaway with few highlights on sensors and mostly on my research area. That is my completely. I was from my electrical background, and then after joining in Maldives. So if you are not able to hear me, please just text me here. Hello. Yes. Are you audible? Am I audible to everyone?
Yes, ma'am, you are audible, right?
Yeah, okay. Because the
Audible,
timing is
madam?
also different. Yes, okay, thank you. The timing is also different from Maldives and India. So that's what, because just now we have completed a session. So if you want to have a break for 10 minutes, it's fine for me. Otherwise, we can continue as it is. Um, my interest, that is my PhD title is Wide Area Networks. That is WAMS, Wide Area Measurement Systems. That is Phasor Measurement Unit. It is also a kind of sensor for power system. So how a power system can measure the phase angle of different buses. Okay. So this is my PhD title. So I hope my background somewhat touches the sensor area, even though I am an electrical background person, and I am supervising some projects based on sensors, and then mostly I am focusing on environment based researches nowadays. So even though it is not focused to electrical engineering, like I am doing kind of a mechanical engineering project also, like engine oil, how to life cycle assessment. Mostly I am doing life cycle assessment of various products like laptop. So we will come through those things when we are in the presentation. In between we will discuss. So I don't want to have a complete session like completely I am talking, then you are listening like that. It's so boring for me also. Just now I have completed a class and I have joined the session. So I know how the stress will be for the staff in India. So uh, make it as a very cool session. You can discuss in between, and then you can interrupt in between and then say this is not okay, this is like that. Okay. So let's start. Or do you need any break? Let me know. Before that, I am setting up all the things. Even though that I will start like Indian time 7:30, right? Now it is 7 here. I hope we 7:30, right, in Indian time. So we can start right now, I think. So are you recording the session, sir? Should I do from my end?
No, ma'am, no need, ma'am. We are recording the session, ma'am.
Okay. Okay. Are you seeing my slides?
Yes, ma'am.
Okay. So the title I'm going to present now is Environment Monitoring Sensors. I'm Dr. Nafina Abdul Munaf. I'm Assistant Professor in Faculty of Engineering and Technology, Villa College, Maldives. So the contents which I am going to cover today is environment monitoring sensors, types, applications, and few case studies around the world. Like case study 1, like air quality monitoring in urban areas, water quality monitoring for recreation, soil moisture and nutrition monitoring. Case study 4, flood monitoring with low-cost sensors, and case study 5 is the weather monitoring. So I just wanted to give some briefs from the researchers, and then from also from the world, from different countries, how this environment monitoring sensors are implemented, and how its effect is promising in everywhere. Okay. And then some challenges and future trends of environment monitoring sensors also I'm going to touch. So before starting my session, I just everyone are like, you might be an expert in this area even, but still I want to start like to how my students I will tell like what is environment monitoring sensor. So it is a sensor which ensures a sustainability, right? Sustainability through smart sensing. Shall we say like that? So environment monitoring sensor is nothing but ensuring sustainability through smart sensing. So sustainable development, everyone know, right? So anyone, can you tell what is the definition for sustainable development? Yes. You can also see and read. So what is SDG goals? Everyone are now talking about SDG goals, right? Always SDG everywhere. So now if you are going for a funding, if you are searching for a proposals, or if you are searching for a call for a grant, everywhere we can see the word sustainability. Why it is so important about sustainability? So just a definition, this is a very important, like what to say, important in the sense, practically it is clearly framed by United Nations. Those United Nations are the foundation. They are doing lot of researches and lot of uh, studies for mainly for the sustainable area, mainly for the crisis, what to say, like global warming or depletion, or ozone layer depletion. So many things, the research is happening through the United Nations. So they have given a definition for sustainable development. Is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So now we have everything. Are we preserving everything for our future generation? That we have to think about, right? So everything, now we have water. Whether our grandchildren will have enough water to drink or for their regular use. So this is the clear definition of that. And in environment monitoring sensor, a definition we can say it is any sensor which is device used to detect some physical signal, right? Detect and measure environmental parameters. So importance mainly to help in climate change studies, disaster management, or pollution control. Those are some important studies, importance of environment monitoring sensors, and mainly applicable to industries, agriculture, research area, and urban planning stages. So types, we can see, first I'm just covering a general area about environment monitoring sensors. So types means, particularly if we say environment monitoring sensors, if we say sensors, then there are a lot of types are there. But when you particularly say environment monitoring sensors, mainly we are having these kind of sensors for applications like air quality sensors, water quality sensors, soil moisture sensors, temperature and humidity, noise level sensors, and radiation sensors, gas sensors. So we all know now completely we are going to, that is due to fossil fuel, there is completely CO2 emissions, and then this uh, all the what to say, greenhouse gases like methane or nitrous oxide, everything is now creating a lot of issues. So we are moving to green energy, we are moving to green buildings. So we are avoiding all the kind of fossil fuel usage, right? So these things have already created lot of issues in the environment. So we need a methodology or technology, something to address this. And then as an engineer, we are providing a technical solutions to overcome these things through our environment monitoring sensors. So particularly if we say air quality sensors, we have CO2 like pollutants like carbon monoxide, CO2, nitrous oxide, and then so many greenhouse gases, and then particulate matters like 2.5 and PM10. These are all some important pollutants in air. Okay, so to address these things, to sense these uh, kind of pollution, we are going for air quality sensors. So mainly in smart cities and indoor and outdoor air quality monitoring, we need these kind of sensors. So are you here, everyone? Yes, say yes. All mics are muted.
Yes, ma'am.
Yes, ma'am.
Okay.
Moral
So what are-
Yes, ma'am.
Okay. So water quality sensors. So water quality, we have to measure the pH level of water and dissolved oxygen mainly to protect the marine lives. We need to do this also to consume a quality of water. We need to do kind of sensing these elements like pH level, dissolved oxygen, turbidity, and contaminants in the water. So mostly we are using optical based, electrochemical or conductivity based sensors we are using for water quality, mainly for drinking water safety, wastewater management systems, because we have wastewater management system. So where we can say waters, we can classify into different types, right? Green water, gray water, blue water. Green water means the water which we got from rain. Gray water is the recycled water. So when we are doing wastewater management, we need to check whether the treatment, after the treatment of the wastewater, we are having a that is what purified water or not. How we know, which ensures the purity of the water. So these sensors, water quality sensors, will be having a impact on those areas. And soil, if we think, then if we are talking about soil, we will directly think about agriculture, right? So how we can use soil moisture sensors, not only moisture, what are the sensors technology we can adapt to agriculture and to improve the agriculture and then to protect the environment. So those kind of sensors also we will see. So we are seeing like volumetric, tensiometric, and gypsum block sensors are used, particularly for soil moisture sensors, mainly for farming and also erosion control. And we all know temperature and humidity sensors. Um, yes. Yeah. There is a hand raised. Any question? Okay. So temperature and humidity sensors, in the sense we use thermocouples, RTDs in industries. Mainly, we can say, for example, you have a boiler, you are having, you want to measure temperature, industrial automations, because most of the industries now we are working on industrial automations. They have a lot of heating process and cooling processes in industries. So they need some temperature based sensors, we can say. That is for industry. We are using thermocouples, RTDs, capacity humidity sensors. Those we are using for industry. When particularly we are talking about environment, how this temperature and humidity sensors will be having a role on it. Okay, because we are talking about temperature rise, right? So when we are saying global warming, we are saying the entire world or every country, that there is a temperature rise. Year-wise, the temperature rise, it is already, this problem is already addressed. So how this thermocouples, RTDs, these things are going to be a solution, are going to provide a technological solution for those atmospheric changes, temperature changes and humidity, those things. Okay. So weather stations, where it is used, this temperature and humidity sensors, particularly weather stations and industrial monitoring. And we know noise level sensors, so detect sound intensity in decibels, MEMS, piezoelectric sensors are used for this purpose, mainly in traffic areas and industrial noise areas like power plants. If some like Maldives, like places have very limited area, we have Maldives like country, so it's like island. So we don't have like a place to keep power plant or our industry out of the places, out of the city. Okay, so everything will be there around these. So all the industries or even power plants, even very walkable distance, it will be there. So the lot of noise will be there. So how these sensors will, we can use these sensors to arrest these problems, particularly for a country like Maldives, like island country, island nations. And radiation sensors. So we know we are having a Kudangulam power plant very nearby in Tamil Nadu. So we know how the effect of the radioactive materials, alpha, beta, gamma materials, when it is mixed in the air or it is in the water, how it's going to be a problem, how it's going to be a pollutant, we know. How we are going to be affected also, everyone will know. But rather talking about, instead of talking about these are the problem, these are the like what it's going to be an effect to the environment, like we are talking about, but there is a solution for this. Out of it we can have awareness, and we also have it, we can adopt these technologies to the places nearby, and then at least we can save some of the drawbacks though caused due to those nuclear power plant emissions. And applications, yes, this is smart cities, pollution and traffic monitoring, or in agriculture, say precision farming, soil health assessments, industry mainly for compliance with environment regulations. So these are all some important applications, particularly in research. Now there are a lot of research for ecological footprints, carbon footprint finding, and then climate change. Mainly, there are a lot of researches are going on. So all the data, how the data taken from these researchers, how we can analyze, how we can use the AI techniques or machine learning techniques, or how the images images can be studied properly through different learning algorithms, self-learning algorithms or deep learning algorithms, how it can be studied, and those things can be done. Those kind of researches are happening for environment monitoring sensors, mainly in the areas like climate change and ecological studies. So some of the sensors which is used as the environment monitoring sensors I have given. So PM S500, this is mainly for particulate matter. So it measures PM1, PM2.5 and 10 concentrations detection. So we know some micrometer particles which present in the air, which even we don't know, because which even we can inhale it, right? So if we are inhaling it, these particles, these inhalable particles which are less than 10 micrometer is very, very dangerous to our health. So these minute particles can also be measured using PM sensor, which is one of the air quality sensor. Its concentration ranges from 0 to 500 microgram per meter cube. So the 1, 2.5, 10 given is a diameter. So one is a very less, like one diameter. The diameter will be 1 micrometer, something like 2.5 will be 2.5 micrometer. Particulate matters will be there in the air. So mainly in the polluted cities like Hyderabad or Delhi, those places are very traffic areas. So this PM will be very much high. So this can be detected using the PM sensor. And also it is used in variety of applications like So we can also monitor and also purify these particles using air purifiers. Now there are a lot of technologies are there in air purifying. So indoor air quality monitoring. So even with the HVAC system, we can now the new HVAC systems are already incorporated with this PM S5003 sensors only, but still it is detecting. So in air further we can have a technology something like to say air purifier also, if it is included in the indoor air quality monitoring system. We are adopting it to the HVAC system like air purifiers. So that will be more helpful for the people like underage or old aged people. So particularly they will be affected by these things. The adverse effect of these kind of pollutants will be there only for the people, those who are in those problems, lung problems, asthma patients. So those will have the very worst effect on these kind of PM particles. So nowadays there are some wearable devices also is there, like air quality monitors. And industrial environment, particularly the people those who are living in industrial environment, can have awareness about their PM level in the air, and then they can do some remedial actions using these kind of technologies. Particularly in automobile industries, those who are working in automobile industries also, it is very much important to monitor this kind of problem. And MHZ19 is a CO2 sensor. So carbon dioxide emission, we know we are using due to traffic, due to the fossil fuel usage. We are already CO2 emission is completely there in the air, okay, which is having a lot of problems, which causes a lot of problems to the environment. Okay, so CO2 sensors, it is enabled with the like IoT technology. So we are having a particular system, or if every places like in a home even, or in an industry or a public places, like these things are there, and then there are some policies are there to avoid these things, or if it is incorporated to the regulation itself with the government, then most of the global warming, those things will be resolved earlier. And MQ131 is a ozone sensor. So we all know ozone is an air pollutant that like it is like it is also like a kind of a greenhouse gas, so which is very very worst effect to the environment. So it also have like ozone concentration range 10 ppb, means parts per billion. So this is the variant we have for this range for ozone sensors. So here we can monitor the air quality using this sensor, and then it is mainly used for air quality monitoring devices and HVAC systems and industrial safety places. And this is also one of VOC sensor is a volatile organic compound, which is like we know some chemical compounds, right? We are using so much of detergents and so much of chemicals. Also, we are using even indoor, in room itself, we are using a paint, we have varnish. So we don't know these kind of pollutants are already mixed with the air and we are inhaling it. So these kind of sensors should be adopted in the indoor system itself. In outdoor also, it should have been implemented mainly for smart. Now we are going for smart home. Smart home, we can connect everything through our IoT means. So we can also have a awareness about our air quality around us. And temperature and humidity both can be detected using DH2T22 sensor. So mainly for weather forecasting, and places like completely Chennai like places are having a frequent flood in those places. So we need to have a remedial measures like this technology should be there. Even though the weather forecasting is there, but still we couldn't what to say, we couldn't find that sometimes the rain, or sometimes for agriculture, people will be expecting a rain. So the climate changes, so many climate changes is there. So though these things can be like temperature and humidity, like everything can be recorded properly, the data is properly analyzed, and then it is given to the public, and then public have awareness about this, and many remedial actions can be taken, preventive measures can be taken before the worst weather conditions. And DS3231 is RTC module. It is used in wide range of applications, like mainly for clock and calendar function. So any devices, IoT based things, when we are using, we need a data logging system, right? So for data logging, we are using this kind of sensors. Also, this is also a low cost sensor for temperature and humidity. So air. So why we have to protect air? What you can see from this image? Anyone? Yes? You all are here, or I'm only talking? Anyone here can answer what is the image representing? There's
Ma'am,
no.
in future, it is very difficult to even breathe itself, ma'am. If we
Yeah.
don't grow the trees.
Yeah. So we need to we are going for urbanization, right? Deforestation. We are cutting all the trees, and then we need to
Yes,
have more. Yeah. So also with a little oxygen. So forests are called as carbon stock. You know why forests are called as carbon stock? Anyone?
after the deforestation, all the woods become carbon due to the earth under earth heat, madam. That's why it is called carbon stock.
Carbon stock. Okay. So almost correct, but actually, if carbon stock in the sense, why we are saying forest are carbon stock in the sense, we are inhaling oxygen, right? And then how we are getting that oxygen? So if we are, the CO2 emissions are all all the greenhouse gases are around the air, right? Mixed in the air, CO2s. So how only solution is this trees and forests. Forest is the carbon stock, means it is consuming CO2. So only way we can reduce CO2 is forest, but we are going for deforestation. So finally, in future, we may be rely on this kind of things may happen in the future. That's what, just for a fun, I have taken some photos like this. See, we are cutting the trees, and then now, if we are playing with the environment will one day will be, it's going to destroy everything, right? What do we do with the growth if we cannot even breathe properly? So many technology we are talking about. So yeah, what is this? Here, son, I saved all this money for your future, but he never saved oxygen, a proper oxygen for his son, right? Even though the technologies are there, even though everything advancements are there, but we don't know, we can't predict our future generation will have all the technology, but I don't think they will have the proper naturally available things what we got. They will get or not, we don't know, right? So pollution is persistent, pervasive, pernicious, and it kills. So there is a, I just taken some case studies for in places happening around. So air quality monitoring in urban areas. This is a case study done in Hyderabad. So what they have done is around the entire city, they have entire state, they have 49 IoT based PM monitoring. Particularly, they are concentrating on PM monitoring device because the traffic is very high, and then they are they have done a research that the particulate matter is very high in the air. So particularly those kind of IoT based devices they have installed in some locations, and then due to the deployment of that they can measure their greenhouse gas emissions like nitrous concentrations. So it should be within CPCB limit, means United Nations have given some, WHO, World Health Organization have given some limits for these concentrations in NOx or nitrous oxide, SO2. These concentrations should be within this limit. So they can monitor it. Also they can check whether they are following within the limit or not. So here you can see lowest in summer, highest in the rainy season due to increased traffic from 4-stroke engines. This is nitrous oxide. Likewise, SO2 also higher in winter compared to the rainy season and summer seasons due to traffic density and atmospheric conditions. So mainly in this city, in Hyderabad city, they have main recommendation for them is high two-wheeler density is a major factor, and then they are going for electric vehicles. This is a from the data taken from the IoT based enabled sensors. They have tracked this. So we are celebrating Deepavali, right? So you can see the curve, sudden rise due to, so this is the PM10, which is a particulate matter 10, which is mixed in the air. Okay. So before bursting of firecrackers, you can see how much is the PM10 density, and then how much it is increased due to the bursting of firecrackers. So we should also think those things. See, sudden drop due to rain. So the rain, those things, the naturally available things will also reduce these effects. But what we are doing, so we are celebrating festivals like things, but to enjoy, we are polluting the environment. So we can do something differently, or we can protect the environment different way, just for ourselves and then for our what to say, our relatives, our friends and relatives, right? And then water. So water is the biggest problem nowadays. See, did we thought about how much water we are using to make any product? So as I have told you, there are different waters are there, right? Green water, gray water, blue water. So there are a lot of technology now. Gray water, recycling. So that is in environment we can say we used to say 3R concept: reduce, reuse, recycle, right? So in environment sustainability, we always we want to adopt 3R concept: reduce, reuse, recycle. So grey water recycling projects are available more, but still we don't know how much products, how much we are using water usage is there. Even we don't know how much we consume water in regular basis for taking bath or for washing the vessels or any other normal household uses. So there will be a highest water stress by 2050. This is the statistics taken from I think this is about statistics taken from some organization. So they are saying that projected ratio of human water demand. Human water demand means ratio. So it will be the stress level will be very high in 2050. They are saying. You can see some we can see some colors are given, right? We can see India is showing extremely high human water demand. Can you see that? So among the countries, few countries are in this brown shaded region, right? India is also one of the region where it was mentioned as a highly stressed places where human water demand is high. So too much of water is also a problem. Too less of water is also a problem, right? I have given a video, but we will move through the slide. So water stewardship in 2000, global water use stood as 3,950 kilometer cube. See, for 2030, global water demand is projected to be 6,900 kilometer cube. So 40% it is exceeding from the supply. So how we are going to meet this demand? That is what we are talking about sustainability everywhere. This is not just like a term which is so addressing, not like that. So we have not faced yet, but still we are going to face so much of uh, these kind of issues in the future. So the second case study which I have referred is a water quality monitoring for recreation system. So this is in Australia. They have done a survey, like most of the people, those who are in recreation like swimming, those are getting mostly affected by waterborne diseases or some kind of what to say, the due to the effects of the water quality, the people are getting affected. So they have invented a device called a mini dot. So this mini dot logger is nothing but a sensor. Okay, so it's a water quality sensor. Basically, it will measure the dissolved oxygen level. So for marine life also, we need to have some kind of sensors like this. We are like the environment protection in the sense only we should not think about the human, because everything should be balanced. Like all the organisms which is there in the universe, there should also be there, because lot of extinctions are there. A lot of organisms, lot of living things are in extinction, right? So that is creating a imbalance between the lifestyle. So these kind of technology should be adopted everywhere, not in the places like Australia. Even in India, that air quality monitoring sensor is there in Hyderabad. Why it was not implemented in some other places? Why it was not implemented in other states? So these kind of things we should have, and then we have to promote these kind of projects to the students, and then like also there are a lot of opportunities, funds, grants based on these kind of projects are now very much wanted. But we can see the same type of projects are always happening, right? So these kind of projects we have not thought about, right? I'm not sure. I have not seen any projects like this, like a submersible sensor which is continuously storing the data of marine life or dissolved oxygen. Or we have any projects like that? Anyone did this one? Have anyone studied this anywhere? So you can also just share your experience, what kind of thing we can do for water quality particularly. If you have come across any technology, or that also we can share.
No, ma'am, I'm very new to this topic.
Okay.
Just now I am exploring from your presentation, madam.
Okay. So mainly, if you see, like here in Maldives, we will say marine life is very important for them, because they live in the their business is completely depend upon the fisheries. Okay, so dissolved oxygen, that the fishes will be having a life only if the oxygen level everything is high. Due to lot of pollutants like the plastics and polythenes are contaminated to the sea, now the oxygen level is going low. So if we have to monitor it properly, otherwise, and we have to do some preventive measures using these kind of technologies like mini dot. So what happening in this is, it is a opt-out sensor. It replaces a fluorescence method. Fluorescence method is nothing but like a fluorescent light. It will show the data like dissolved oxygen concentration, how much it is there. It can measure it. We can collect the data from the data logger, and then also there is a temperature sensor. Sometimes the water temperature changes also can be monitored using this. So they are using some even internal SD cards for this kind of device, and then
Madam? Ma'am? Ma'am? Is there any technical glitch, ma'am? Ma'am? Is there any technical glitch?
Sir, yes.
Okay, she has gone out. So participants kindly wait. The resource person will come within a few minutes. Participants kindly wait. The resource person will come within a few minutes. There is a technical glitch on that side. So kindly wait. Participants, a kind request. There is a technical issue and a glitch on the side of resource person. So kindly bear with us. She will be into the session within a few minutes. Thanks for your patience. Thank you. Ma'am, actually, there is a internet connectivity issue on the side of resource person. So she has not. She is trying to connect. So kindly bear with us. Thank you.
Hello, everyone. Sorry for the interruption in between.
Yes, madam. We can start. Thank you, madam.
Yeah, yes, sir. Thank you.
Thank you.
Actually,
Thank you.
I think before it was interrupted, so once it is interrupted, my network also it might be
Okay,
not.
ma'am. Okay, okay.
Okay.
Carry on.
So I am again presenting my screen. So this has sand resources, how much it is, why it is going, prices are high. So why the scarcity is there, and then about soil health. So we depend up our food depend upon the soil, right? So core functions of soil is like not only food, it is also providing us gas supply and exchange, water storage, nutrient supply, physical support, everything is there, right? So all the minerals in the soil should not be affected due to these environmental issues. So we need to monitor the soil nutrients or soil quality using some appropriate sensors. So degraded already 75% of. So according to the World Atlas of Desertification, 75% of them are already degraded. Yes. Any queries? Any clarifications? Okay. So 73, also one way we are facing hunger and so many things due to the soil health also, right? So we are not getting it because completely pesticides, we are relying on pesticides and everything. So that can also be monitored and given in a proper ratio using sensors. So 557 farmers died by suicide in Maharashtra in first 6 months of 2024. This is a state government report. And in US, suicides in 2023 still at highest level in nation's history. So these are all due to the difficulty of farmers. Why they are facing the difficulties? The technology which is not adapted to the agriculture, also one of the effect of this we can say. And then soil erosion. We are having lot of soil erosion. So recently we have uh, Wayanadu, right? So Wayanadu we have seen a disaster. So why it was not, in which way we are lacking in technology, where we have to monitor this regularly? Why even though invention of these sensors, why it was not reported before that those people are even while sleeping, so many people died. So it happens. A beautiful places like Wayanadu, these kind of things happening due to soil erosions. Whether we are adopting technology for those things, it's a very big question mark. So we get our hands dirty by restoring our soils and land, right? So this is not like only about us, about lot of organisms or lot of living things in the soil. It depends upon the nutrients of the soil only it is living. Hope you have enjoyed this video, so colorful video. So we are completely our that is our lifestyle, everything is affecting the complete ecosystem. So we should be having awareness of those things. And there is a case study I have encountered, like in soil moisture and nutrient monitoring. This is this is implemented in Netherlands. Okay, so the technology they are using IoT enabled soil sensors to optimize irrigation and fertilization. So this is not a very new concept. It was there already. Everyone know uh, impact on crop yield and the resource conservation. Like so, we can also sense the nutrients and then soil health, everything through sensors, and then we can provide a platform which can analyze the data using AI, and it is taking decision to for example, automatically healing, self-healing. If it is the soil health nutrient level is low, so what is the actuation have to be happen? What is the action to be taken? That is AI is taking the decision to do this. So this is implemented in Netherlands in smart agriculture. So they are having a robo like this. So it is monitoring the soil nutrients, and then automatically it is spraying through satellite. They are monitoring the data, GPS. They are monitoring the data of climate condition, everything, and then they are spraying the pesticides, water, everything automatically. It's completely and protected by the like the technology. Complete technology is protecting the soil. So data acquisition. So this is also data acquisition is also very important, because we don't know today how the soil health is, tomorrow how the soil health is. So what is happening to it? So we are also saying like many flies are there in agriculture. So why it's happening? So we have to process those data. We have lot of people are doing image processing. I have seen lot of papers in image processing. So how much we are implementing it? So everything is like researchers are sleeping in papers, right? So challenges and future directions. So authors identify challenges such as data interoperability. So even though we have data, how we are going to use it? Also privacy concerns and the need for user-friendly platform. So still we are lacking on that. This is the challenges faced by introduced in the paper. The advocate of the for the development of standardized data management system and policies to facilitate the transition towards agriculture 5. So industry is going for revolution. So agriculture should also have a revolution, right? So we have to adopt these technologies. Some of the clippings I have taken from global perspective of floods. Now we are going to talk about weather condition. Germany 2022, flood in Pakistan, Kerala, flood in Tamil Nadu 2023. I hope it is Chennai. Flood in Sydney, July 2021. Flood in Bangladesh, July 2022. So many countries are having still these kinds of issues due to climate change. So which country is this? You can see, you are seeing in the right side. Anyone can guess? Happened recently. How many of you visited Dubai? Is it Dubai? Yes? Am I audible? I'm going to ask questions now. Are you all there, or again my connection is lost?
No, ma'am. Yeah.
Yeah, okay. So I have to check in between this also, right? Before I was talking, going on talking, and then I just see some message that it is disconnected. Okay. So So 1.8 billion number of people facing flood risk worldwide. So there is a flood monitoring with low-cost sensors they have enabled in Queensland called Lixia. So Lixia-based technology, they have implemented affordable flood monitoring sensors which provides a real-time data and early warnings for flood-prone areas like Australia. Okay, so it is also utilizing the technology, IoT technology, and it measures water levels in rivers, creeks, and overland flows, and it is giving the awareness to the people, everyone, those who are having it is like a mobile app they have created, so everyone are getting that is yearly warning about the flood conditions. So it is providing a situational awareness, right? So the situational awareness is missing everywhere, like due to these places where the flood has happened recently. And due to the temperature rise, we know the melting of ice is happening, right? See, what is this? Ice spheres, right? So there is no place for it for these kind of creatures to live. So the melting of ice increases the water level. So sea level is rising. Even they are saying there is a say that Maldives will be completely covered with water in few years like that. Like not only Maldives, Japan is also an island. So there is a study like this temperature rises it will predominantly increase the water level, and there are a lot of there's a lot of issues going to be happen due to that. So how we are going to predict these kind of climate actions? As climate change heats up the tropics more than the poles, it strengthens the wind shear, the change in wind speed and direction with height. So tsunami is not only the cause of tsunami is one of the temperature rise is also one of the cause of tsunami, we can say. So I hope you all heard or have watched the news recently, the wildfire in 2025 California. So you can see 2022 it's completely dropped, and then in 20 I think it is 23 it is completely snowstorm, and 2025 it's a wildfire. So we can't even predict the climate if it is in these kind if these, so how they can say, is it a temperature rise, or is it a melting of ice, or is it a soil level problem, or is it a rain scarcity of any water resources? We cannot even predict, right? So this is a survey taken from Australian Academy of Science. So how much variations is there in hot days per annum for each decade? How many days hot days? So it is completely not like going in a proper cycle, right? So there is a meteorological agency in Japan. They employed a network of observation stations completely through satellites and radars. So radars, I hope you all know, radars, sonars are the technologies, advanced technologies, right? So what is radar? Anyone? Yes. So it's a radio wave technology. Using the radio wave technology, we can determine the distance, direction, and radiational velocity, which will also predict the weather conditions. So here, the emergency warning system, it was launched, and this system issues alerts for natural phenomena of or extraordinary magnitude, urging residents. So there will be a if you are seismic waves, if you are going to monitor properly through the data collected through these kind of meteorological stations, properly enabled with the weather monitoring sensors, so we can study the data and we can predict the pattern in the early stages itself, right? So this is also like a mobile app. Every citizen are supposed to install it, and then the complete statistics of weather conditions are they can access, and then they also have a situational awareness thing. A mobile application providing real-time alerts for earthquakes, tsunamis, volcanic eruptions, and severe weather risks tailored to users' locations to enhance personal safety. So even though we are adopting lot of these kind of technology now, it is evolving, right? So now the sensor technology is more. Now we are going completely on AI, like IoT, AI, and then so many what data-driven algorithms. Still, we have a lot of challenges in these kind of environment monitoring. Mainly, we can say a few concerns like data collection issues. So sensor coverage is a important problem, right? So one of my students have done a project low cost sensors for weather monitoring. So I asked him to set up the sensor coverage, like just to show the prototype. I have asked him to cover a particular area. So we have came across a technology called repeaters. Now the repeaters are there, right? So even though that is also not affordable range, right? Cost, everything is also a important thing here. So when we are adopting sensors, there should be a coverage area. We should have a large coverage area. So like also, we cannot mostly implement this in remote areas, oceans, underground environments. So that is one difficulty. And high cost equipment malfunctions is uh, we should have a proper technology to automatically heal the faults if we are adopting these kind of things in the unattended areas like marine or in underground any places. Data accuracy and reliability. So completely we cannot take a decision from a machine, right? If a machine is saying tomorrow you are going to have a earthquake, so will everyone will rely on that, right? Whether it is accurate. So that is also one of the challenge, right? Sensor calibration issues. Inaccurate or poorly calibrated sensors can lead to misleading environmental data. So many interferences are there, and data overload possible. And like challenges, integrating and sorry, G I missed in my presentation. Integrating and standardization. So lack of unified standards. So different organizations and countries are using variety of measurement standards. Like I have shown you different countries, they are using different kind of sensors. So why we can't have a universally accepted sensors, universally accepted technology? Why there is no integration in these kind of standards? So if you can see, for example, I will say, if you say a thermometer, right? So everyone we are having a proper standard for it, right? Interoperability is very good. But when we are going for technologies, that should also have a proper standard and which should be universally accepted level. Technological infrastructure limitations, connectivity issues. So even now we have encountered a connectivity issue, right? When we are completely relying on internet data, so there is a completely we are relying on communication network. So there should be also a proper technology to always address these kind of issues, lack of reliable internets or communication networks for real-time data transmission. Energy supply. Monitoring stations require a stable power source, which is challenging in off-grid areas. So when we are talking about these kind of sensors, we cannot always provide power. When it is used in the environment monitoring, cannot be done only in land side, right? We have to think about the difficult areas where we are going to place these sensors, like underground or like places like a pipeline. In industry, a pipeline you are going to keep a sensor. So how it is supplied, how the energy is supplied to it. So it should have a self-powered one, right? We cannot go and place solar panel everywhere. We cannot go and place a source. It should automatically produce power on its own, like a piezoelectric sensors, those things. So challenges, environment and climate changes. Yes, it is a very big challenge. Extreme weather conditions, harsh climates, storms, floods, extreme heat can damage monitoring equipment. So aerobic environment threats means new pollutants. We know some pollutants like ozone, CO2, or chlorines, or kind of greenhouse gases. But if there is any new pollutants which we never ever studied, so how we are going to, how it will affect the technology. Climate change impacts and emerging environmental risks require continuous adaptation. Regulatory and policy barriers. Yes, still we don't have a proper regulations. We cannot use AI everywhere. I cannot use a drone camera in a particular places where, for example, there is agriculture area nearer to airport. I cannot go and use a drone area to monitor it properly, right? Am I correct? So there should be some policies, regulations for this, and lack of funding and support. People are talking about environment sustainability. Lot of funds are there. Really, it is reaching to the potential projects. That is also one big question. So, public awareness and engagement. So, how much people are participating in these things? How many people know are well versed in technology? Even though technology they don't need to have, but the system should be able to reach the people, those who don't have education, right? So misinformation and misinterpretation is misuse of data, because now we don't have any security of our data. So we have to go for many technologies in cyber security. So wherever we are thinking of wide area network data, we have to think about cyber security also, right? We are going everything smart. Everything is going to smart. So in that case, security is also a big question mark. These are all some challenges, ethical and privacy concerns. Yes, ethical issues will be there. The data, when we are talking about data, weather monitoring data or air quality data, so I cannot go and if people are living in a particular area, apartments near, I cannot go and place a noise level sensor, right? I cannot monitor it. It will be a ethical issue. So there should be some standards for that. So ethical use of AI. Using AI for environment monitoring requires transparency and responsible data handling. Right? Data is not handled properly. That will also going to be a biggest issue due to the uh, misuse of data. So if you say future trends in sensor technology, so we have lot of inventions. Now we are moving towards lot of sensors, nano sensors, miniaturized sensors, wearable sensors, implantable sensors. So more efficient sensors, like very smaller size. Even we have like sensors. These sensors we are using like for spying some places also we are using, right? Wearable sensors, smartwatches and health monitors with advanced biosensing capability. And AI powered smart sensors. There are so many technologies like edge computing, self-learning, predictive analysis, kind of things are there. So even Netflix uses edge computing technique, right? So anyone know what is edge computing? Anyone? So now everyone are going for cloud, right? If you want to process the data, we need to rely on cloud storage. Even Gmail started asking to payments now. So it's a private cloud. If it is giving us private cloud, we can get a private cloud even in terabytes from Gmail, right? If we are able to pay. So if we are without cloud storage, also there are some technologies which AI-enabled sensors that can process without using the cloud storage. Locally, using the data, it can do. Self-learning sensors, so machine learning algorithms which improves accuracy over time. Predictive analysis, sensors identifying patterns to forecast failures and optimize performance. So there are a lot of self-learning algorithms are there. We can train our sensor based on the previous models, and then it can be a decision. Since it is AI powered, it can be a generative AI is there. It can take decision and it can also implement it. Wireless and IoT connected sensors. So 5G and beyond, we are going now faster and more reliable data transmission and low power networks. So low power wide area networks are type of wireless telecommunication, right? So wide area network is designed to allow long range of communication with a low bit rate using IoT. That is also now advanced one. So even my research is a wide area network. Uh, the device which, for example, I'm talking about phasor measurement unit. So before we have SCADA. SCADA is also a kind of measuring device. It will store the data in milliseconds, but it is not time stamped. Okay. So through GPS, if you are able to timestamp the data, so all the sensors placed should be timestamped in a particular interval. So otherwise, the data taken time. For example, if I am measuring something in Maldives at now, it is Maldives time is 8:15 p.m. Can someone tell what is the Indian time now? I hope it is 8:30 there.
8:46, ma'am.
8:46.
Oh, okay. So I am running out of time. Sorry for that. And then, sorry, there is an interruption also in between. So I have to go more than my allocated time. So likewise, it should not, if a sensor, if for example, if every sensor is interconnected in Maldives in India, if something is measuring a data in Maldives at 8:16 p.m. and the same kind of sensor measuring in India at 8:46 p.m. should be same. So that should be time stamped. We are saying that as a time stamping through satellite networks, through GPS signals. Okay, that is also advanced one. Self-healing networks. Self-healing is, for example, if it is diagnosing, if my device, my phasor measurement unit device is diagnosing a fault, it will automatically send a signal. It will automatically correct the fault. That is self-healing example, right? Automated. We no need to look for the other measure to correct it. Energy efficient and self-powered sensors. Yes, as I have told you, in many places, if we are employing these sensors, we cannot rely on power supply for that. So we should have a sensors which can harvest energy on its own, like solar or thermal or vibration. Example, we can say piezoelectric sensors, like ultrasonic sensors also. Ultrasonic low power sensors can also be designed without battery. Wireless charging sensors, improving sustainability and reducing maintenance. And some of the advanced environmental sensors, air quality and climate monitoring. That is also some advanced sensors are there. Water quality sensors like pH level, contaminants, temperature changes can be detected. Agricultural sensors, which enhancing precision farming. So automatically it will check the soil level, whether it requires any pesticides, whether it requires water. It can automatically take a decision, AI driven. So it can automatically pour the water or nutrient or pesticides to the um, what we will be training the robo in that way. We will training our system in that way with the previous sessions. So quantum and biosensors are also a very advanced one. Quantum sensors, it's like a microscopy, positioning, electrical and magnetic field sensors. So we have seen lot of electrical and magnetic field sensors. Using that technology, magnetic field technology, this quantum sensors can be used. which can offer ultra high precision for detecting magnetic fields, gravity, and time variations. Like earthquakes can be detected easily using this. Biosensors detecting biological molecules for applications in healthcare, food safety, and disease diagnosis. So we all know now a lot of biosensors we are using, like DNA microarray, and then lot of glucose monitoring, those things, blood oxygen level monitoring. We are using biosensors. DNA and RNA based sensors also available, rapid disease detection and monitoring, like cancer cells can be detected easily using this. Flexible and stretchable sensors. Nowadays there are a lot of technology in there, in e-skin technology. Likewise, have you ever heard e-textiles? So the textile which can produce, the textile means the fabrics can produce energy on its own. Likewise, we have e-skin technology. These are wearable sensors. It mimics like a human skin. It improves the what is that, prosthetics and robotics. So it is like mainly used in medical field. Flexible electronics, printed sensors on fabrics or curved surfaces for enhanced usability. So we can, flexibility is there for the sensors which can be converted to any shape where we are going to use it. Multifunction and hybrid sensors, multi-parameter sensors, sensor fusion technology. There are a lot of things are there. Like I have told you already, radar, sonar. Sonar is the mainly used in marines. That is sound navigation and ranging. So by detecting the sound itself, because in all frequency signal, all frequency decibels we cannot hear, right? But we can train the sensor which is not in the audible level to detect it, and then check some anonymous interruption is there in the particular area. Likewise, we can detect it. And we can go for ethical and secure sensor networks. Yes, cyber security based, privacy preserving sensors. So now we are there are a lot of data are involved in entire industry or entire environment everywhere. So hacking of data is possible. So we need to have a cyber security based system when we are adopting these things to completely to a particular city or to a particular public places. So just a fun, I just gave this image. So the father is saying this is the hottest summer of my life. Okay, but coldest summer for his son. So there are a lot of changes in lifestyle, right? So have you heard about carbon footprint? Anyone? So everyone should have awareness to calculate our own carbon footprint. You can access in Google. There are a lot of uh, sites are there. If you are able to give your inputs, it will show you how much is your carbon footprint. Means if I am using energy, my electricity bill, how much fuel I am using, like road transportation or my own vehicle I am using, or any amount of fuel I am using, how much gas I am using, how much I am traveling through air, like flights or bus or car. So everything, if we are giving data, it will give you a carbon footprint. So there are a lot of surveys. Uh, so it also will say what is the permissible allowed carbon footprint for every person. Okay, that you can calculate, and then you can reduce your carbon dioxide emissions, because we all are rely on fossil fuels, right? Fossil fuels for transport and electricity, or even some people are cooking using electricity, right, nowadays. And then lot of emissions due to air conditioner. We are using what is that, refrigerant. We are using in air conditioners. We are using crayons, and so many things are completely having fluorines, detergents. So those are also producing kind of greenhouse emissions. So we should be aware of those things if you want to protect the entire nation, if you want to protect your entire village, or if you at least protect your home, you should know your carbon footprint. Okay, this is the population growth. I hope you all know these things. 1.8 planets to provide the resources we are using. So our planet is like no other. So this is the time to protect our only home. Can you see the temperatures in the other planets? So only in Earth is the only place you can live, right? Is it possible to live in 140 degree, 110 degree? Not possible, right? So the world has already used up more resources than can be renewed this year. Okay, this is a survey. 2024 overall Earth overshoot day was on August 1st. So let's all try to protect the environment. I hope I have reached you with some insights. Any questions? Yes.
Participants, any queries, please explain.
Participants, if you have any queries, kindly put it in chat box, please. Tools real-time application.
So real-time application means like we have like we are not only covering the particular technology, no. So if we are only focusing on any one technology, we can have a lot of tools are there, right? So now we have covered many technologies, many things. So we can learn about low power sensors area. You can see cover wide area networks. Those kind of things we can see. Real time application in the sense, I'm not sure what you are asking. There are lot of tools in you can use in MATLAB also. You can simulate, right? Wavelets also use, even simple wavelets also you can use. More than that, you are using lot of image processing, environment monitoring. I have seen many applications in image processing, right? So you can use mostly deep learning algorithms for those things, and then you can use all the AI based generative AI also you can use. I hope for small applications like small like RTD, temperature humidity sensor. So what I am suggesting is uh, rather selecting projects for your, if you are a lecturer, if you are a student or a lecturer, for everyone it is common. So selecting a research title or selecting your project title should be at least worth to do some research on particular area, like to help the environment, to help the society.
Participants, is there any other queries? Please put it in chat box. Okay, shall we wind up the session, ma'am?
Yes, sir.
Okay, participants. So thank you very much, ma'am. Thank you for sharing your kind knowledge on the topic. So we thank on behalf of our management and principal. So thank you very much, ma'am. Thank you.
Thank you so much. One student is asking a question. Can you suggest a specific projects for first year students? Recently, I have given a title to one of my student underground marine, like immersible water mini dot. I have shown you mini dot, right? So I will share my presentation with the coordinator of this event. I have given all the links in my presentation. Just check that one, mini dot, okay? So it is a immersible sensor which can detect all the uh, things happening in underwater, right? So that is a good project in environment-based sensors, I can say.
Is
Someone here
there
can also share. Someone here can also share any ideas if you have. Students are asking for projects, so you can measure you can do project to measure the real-time data in places where like I have told you in Hyderabad they have. You can do a case study on that. How in Tamil Nadu how we can implement that air quality sensor, and what are the important nodes we can find out the use cases. Which nodes is important to place those kind of things we can use algorithm to find out optimal placement algorithms we can use. Lot of algorithms are there. So we can use that and then we can find potential locations where we can place these sensors and particularly for weather monitoring, what are all the aspects we can do a case study, what are the aspects we can, what are the data required to study the flood in early stages. Those things are because in Chennai you can see every weather every time there are flood is there, right? People are affected. So why we are not able to predict it before? Why our weather forecasting system failed somewhere in these places? Those kind of things you can do. Really, it will be helpful for everyone. If you are doing a project in those aspects, it will help not only you to the people in the entire world, right? A good project. If anyone, you cannot no need to think about I am in Tamil Nadu. I'm just doing this. Anyone are going to see this or not? Just to see United Nations website. Lot of proposals are announced by them. Okay, now United Nations they have all in every country they have representations. I might be United Nations representation will be there in India also. We all are submitting our proposal to serve, right? DST. Yeah, that is also good. I'm not saying you should not submit, but if you are able to do a good idea, if you have international call for projects, proposals, grants, you just check. If possible, I will give links to the coordinator with my presentation. So you can apply through that. Lot of funds are there for these kind of projects. Okay, I also recently got one fund based on the like recycling in recycling of oil. Okay, thank you everyone. Thank you for listening. Thank you for your time. I hope I have reached somewhere. Still, we will brainstorm many things. Thank you so much.
Thank you, madam. Thank you very much. So, participants, we have posted the feedback link in the chat box. All of you are requested to fill up the same. We will close the link within 5 minutes. So, within that, you fill up the link. The feedback link will be open by 10 p.m. till 10 p.m. today. After that, it will be closed. So, kindly they will fill up the feedback link as early as possible before 10 p.m. We will be open having this meet link till 5 minutes. Thank you very much.
May I end the session?
Okay, madam.
Okay. Thank you.
Thank
Thank
you.
you everyone. Have a good day. Thank you.
Participants, shall we close the link? Close the meet link. The feedback link will be open till 10 p.m. today. So shall we close the meet link now? Kindly respond.
Sure, sir. Sir, sure.
Okay, sir. Okay, thank you.